Hello, today we're going to be covering factoring by grouping, and some people call this factoring in pairs. So this is a method of factoring equations with four terms. What we're going to do is we're going to group the first two terms together and the last two terms together. We're going to factor separately by looking for a greatest common factor, and then we're going to find the common binomial that they both have, and we're going to factor that. So this is very similar to the very first day that we did factoring. Okay, so the problems that we're going to look at would be something like this first example. If we had 2x squared plus 8x minus 1x minus 4. I'm going to start by putting them in pairs, the first two terms and the last two terms. So once I split my problem in half, I've got the 2x squared plus 8x. And I'm going to look for the largest thing that I can divide both of these by. Most obvious case is the 2, so I'm going to divide both of them by 2 to factor out a 2. But I also have 2x squared plus 8x. They both have an x, so I also need to divide out an x. And when I divide both of these by an x, 2 divided by 2 would be 1. X squared divided by x would leave me with 1x. 8 divided by 2 would be 4. X divided by x would cancel out. Now I look at the second half of the problem, where I have negative 1x, subtract 4. The largest value I could divide both of these by would be negative 1. So I'm going to divide out a negative 1 from both of those. And when I do that, that negative 1 divided by negative 1 would become positive 1. Negative 4 divided by negative 1 would be positive 4. So I've got 1x plus 4 here. Now it said find a common binomial. A binomial is a two-term equation. So bi meaning two-term equation. So I'm looking for a two-term equation here in my problem, and I do see one of those. Both the left side and the right side of my equation gave me x plus 4. So I'm going to start by factoring out 1x plus 4. But when I do that, the part I have left is a 2x minus 1. And that gives me my answer of x plus 4, 2x minus 1. So again, I split my problem in half. I looked for the largest thing that I could divide out of the two different little mini problems, factored that out, and then I wrote down my answer. Okay, so example 2. Most of the problems that we see today are going to be like this. So we have 3x cubed plus 9x squared plus 4x plus 12. So I'm going to start by splitting my problem in half. I've got my first two terms, 3x cubed plus 9x squared. And I have the second half of my problem, which will be the 4x plus 12. Now, on the left side, we can start with the numbers. So between 3x cubed and 9x squared, I could divide both of them by 3. I need to look at my variables. I have x cubed, I have x squared. I can take away 2 x's from both terms. When I do that, I divide it out. So I have 9 divided by 3 would be 3. I had 2 x's originally. Factored both of those out. That leaves me with no x's on the right side of that equation. On the left side, 3 divided by 3 would be 1. X cubed, so 3 x's take away 2 x's would leave me with 1x. And I'm done with the left side. Now I look at the right side. Between 4x and 12, well, I can see what the numbers, the largest I can divide out is a 4. But they don't have any variables that are shared, so I'm just going to have to leave that part alone. So 4x divided by 4 would be 1x. 12 divided by 4 would be 3. And just like the last problem, I'm going to look for a common binomial. So I'm looking for the two-term equation that they have in common. On this one, I see we've got an x plus 3 from the left side and an x plus 3 from the right side. So there's half of my answer. The other half would be the two greatest common factors that we took out, so 3x squared plus 4. And that gives us our answer. Okay, so we've got just a couple more problems left to cover. Number 3, we have 2x cubed plus 10x squared minus 3x minus 15. Same deal, we're going to split the problem in half. First two and last two. That way we've got two pair equations. So our first pair, we have 2x cubed plus 10x squared. And the second pair, negative 3x minus 15. So on the left pair, I can obviously see 2. I could divide into both of those. But they also have at least 2 x's, so I'm going to factor out 2 x's from both of these. And when I do that, when I divide those out, 2x cubed divided by 2x squared would leave us with 1x. 10 divided by 2 would be 5. X squared divided by x squared would be no x's left. On the right side equation, negative 3x minus 15, I'm going to divide both of these by negative 3. Now, whenever this second equation starts with a negative, you are always going to make these the greatest common factor negative. You're always going to factor out a negative when that first term is negative. Okay. And so we divide both of those by negative 3. That leaves us x. Negative 15 divided by negative 3 would be positive 5. Now we're looking for our common binomial. Okay, so the two-term equation they both have would be the x plus 5s. So that's half of my answer. The other half would be the two greatest common factors that we had, the 2x squared and the negative 3. And there's my answer. Okay, so question number 4. We've got 4x cubed plus 3x squared plus 4x plus 3. I'm going to split the equation into pairs. So the 4x cubed plus 3x squared, 4x plus 3. And so our first term, 4x cubed plus 3x squared. And our second term, we've got 4x plus 3. So on the left side, 4x cubed, 3x squared, well, with the numbers 4 and 3, they have no common factors. But I do see that the left one, the 4x cubed, has 2 x's, and so does the 3x squared. So I'm going to factor out 2 x's here. And when I divide out the 2 x's from the problem, I've got 4 with 1 x left, and I have 3, and I had 2 x's. I divided out 2 x's, so I have none left. On the right side, though, the largest number between 4x and 3, the largest factor between that, the only thing I could factor out of that is a 1, which would leave me still 4x plus 3. So when I go to write my answer, I've got my common binomial of 4x plus 3 on each one. And then I have what's left, which would be x squared plus 1. Giving me a final answer of 4x plus 3 multiplied by x squared plus 1. Now occasionally we get problems that have more than one variable. It's done the same way though. So on example 5, last example, we've got 3x squared plus xy minus 12x minus 4y. Still going to split it into pairs. So my first pair being 3x squared plus xy. And my second half of the problem, negative 12x minus 4y. I'm going to look for what they each have in common. So I'm going to start with the one in red, 3x squared plus xy. Well, they obviously don't have any numbers in common, but they both have at least an x. So I'm going to take away 1x. I'm going to factor out 1x from both of those by dividing it out, which would leave me with 1x remaining, 3x. And then I have a y, because x divided by x would leave no x's there. On the right side, negative 12x minus 4y. Since it starts with a negative, I'm going to be having a negative common factor. And the largest value between negative 12 and negative 4 that could divide out would be a negative 4. So we've got negative 4. And when we divide out negative 4, and they don't have any letters in common either. One has an x, one has a y. Negative 12 divided by negative 4 would be positive 3, and we have our x. Negative 4 divided by negative 4 would be 1, so we have 1y. Now we look for our common binomial, so the common term they both have in common. So a whole lot of stuff in common. We've got our 3x plus y and 3x plus y. And when we take those out of the picture, that leaves us x subtract 4 as what's left, giving us our final answer, 3x plus y times x minus 4. Okay, so that's it for factoring by grouping. If you have any questions, please let me know.